In this video, we're going to have a look at how this graph of force against extension as well as other measurements can be used to determine the Young's modulus of a wire. So capital E represents the Young's modulus of a wire, trying not to get confused with energy, and it's equal to stress divided by strain. Stress itself is force divided by area, and we're dividing it by strain, which is extension over length. Whenever you divide by a fraction, you're multiplying by the reciprocal of that second fraction, so you can swap it around, and then you can combine the numerators and denominators to get this sum here. Now the gradient of this graph would be a very good representation of force per unit extension, because the gradient is the change in y-axis over change in x-axis. It's best to use the gradient rather than just picking a specific point of force against extension, because the gradient takes into account multiple different values that was used to create the graph, so it's more accurate. How do you find the length of a wire? Well, you can just simply use a ruler. It's not too difficult, but finding the area is a bit more difficult. If you have a wire and you cut it open, what you see is that the cross section is a circle, and what's the area of a circle? Is pi r squared. How do you find the radius of a wire? A ruler doesn't have a high enough resolution to measure small distances, so we've used a micrometer to find the diameter and half it to get the radius. And